Hi everyone, this is Thiagarajan, a retired Deputy Chief Engineer from Indian Railways. The last video I made it for you on curve, that's part 1 video, where I have covered the designation of the curve, the parameters, and the different methods of setting onto the curve. So this video continues to that. So I'd like to discuss something about the design aspect of the curve, namely the radius, super elevation, the maximum permissible speed that can be permitted on the curve, and the length of transition, how it should be calculated, etc. Okay, including the limiting values. So, for the Indian Railway Permit Manual, stipulates limiting values for the various parameters. Okay, so all those things we are going to discuss in this video. Okay, so let's go to the subject without further ado. Okay, before going to the design aspects, let me say something about the curvilinear motion. So, what is curvilinear motion? It's the motion of your body on a curved path. It's called curvilinear motion. It's different from the rectilinear motion, which is it is a straight path. When a body moves in a straight path, that is used to say it's a rectilinear motion. Okay. In the case of rectilinear motion, when the speed is constant, and direction also will also be constant, because as far as velocity is concerned, there are two components. One is speed, another one is direction. When a body moves in a straight path, okay, the direction will not have any change. Okay, the direction will be same. If at all any speed, if there is any change, there will be some action, that will be acceleration, longitudinal. Okay, in the direction of the movement, there will be acceleration, deceleration will take place, but not because of the direction, because direction is constant here. That is why it is not much complicated compared to the curve. But in the case of curve, when a body moves on a curved path, you see, though the speed is constant, but the direction at every point gets changed. Okay, the element of direction gets changed. That is why there will be a change in the velocity. Okay, though the speed is constant, but velocity, it is a vector quantity. It is a velocity gets changed at every point. Okay. So that because of the change of the velocity, there will be the acceleration. So that acceleration is not because of the speed, but because of the change of direction. That used to say it is a lateral or radial acceleration with respect to the center. It is otherwise called, as we used to say, centripetal acceleration, centrifugal acceleration. Okay, it will be in opposite direction. So this is very important. This to be studied, as far as our what are the forces, that will create and will act on the body which is moving on the curved path. That we are going to discuss in the coming slides. Okay. And also further to clear, you see, always, any body moving, any particular body moving in here, the circumference, the circular path, it will try to go tangentially. That means the velocity will be always the tangential direction. It will be tangentially only. For example, suppose we are grinding, sharpening our knives in the grinding stone. So there will be a generation of sparks. The generated sparks always will be liberated. That will be going tangent to the point where the knife is touching. Okay. That's why that is all velocity always okay, it will be directed along the tangential path. Okay, tangentially. That is why similarly even you could have practically experienced even the when our car struck in the mud and there will be skidding of wheel when you are trying to start. While there is a skidding of wheel, there will be mud splashes. So that will also fly tangentially. Okay. So always the movement of the body in the circular path, it will go tangentially only. When we are forcing to go in a circular path, then there will be setting up of forces. There will setting up of forces. There will be because of the direction gets changed, and there will be a radial acceleration or centrifugal acceleration. Okay, it's something about it, and we can discuss further. See here, this is a curved path, and there is a movement of a body and the curved path. Suppose we take the 2 points M and N. that m and n along the arc curved is called distance traveled, but whereas the shortest distance m1 is called the displacement, normally used to say. So always this will be because of the there will be, this is actually the direction, this will be the direction. Suppose the particle your body is there, the movement, the velocity always will be to this direction only. If you take this point, this will be the direction only. So every point there will be the change of direction takes place. Okay. So because of the change in direction, okay, and in what way the velocity is affected, velocity is getting changed, and so that we can see here to elaborately to discuss here. This is a curved path. Let us take a 2 point. Let us take 2 points m and n. So this is your radius. This is your tangent. Automatically this will be 90 degree. Okay. And the next point, when you take n, this is your tangent, and you are drawing in the radius, this will be your 90 degree. Okay. But the speed is constant. Let us assume the speed is constant, but the direction is changed. Here this is the direction, here this is the direction. So we can draw a line parallel to this okay, this second point, parallel to the velocity direction, the velocity vector of the second point. Okay, we can draw here. In this case, this is also 90, this is also 90. So there are two triangles. Let us take this small triangle and this bigger triangle, and both are similar triangle, because in this triangle here is 90, and okay, and this triangle also having the 90 degree, and this angle equal to this angle. Okay, because you see this is the angle del theta, automatically the deflection angle also will be equal to theta. Okay, because when this is two tangents intersecting each other, and this will be a deflection angle, always already we have discussed in the previous video also, curve setting out, the deflection angle equal to angle subcenter, so this theta. So this line is parallel to this line, that is why this theta equal to this angle equal to this angle theta. So the two triangles, one angle is 90 degree, other angle is equal to theta. So it's similar triangle. So taking this similar triangle, let us take, okay, make some equation. The delta V, this is a change in velocity because of the direction, So delta V, because okay, this is the first point, the velocity direction vector. This is second point, velocity vector. So the difference is delta V, that is change in velocity, divided by n. So for a distance equal to mn. For mn, this is a change in velocity. The m1 we can otherwise write, otherwise can be written as velocity into time. So whatever velocity, this velocity, the time taken, that will be the distance traveled. Okay. So delta V by Vt equal to V by R. The V means what? This triangle we have taken, this V by R. Delta V by mn equal to V by R. Okay, similar triangle. So the delta V by Vt equal to, further we can reduce it, that is delta V by T into V squared by R, because we will go here V squared by R. This will be the equation. So further, if we see where delta V by T, that means change in velocity per time, divided by time taken, that is equal to rate of change of velocity. So rate of change of velocity is the acceleration. So rate of change of velocity equal to acceleration. This acceleration equal to V squared by R. This is a basic formula. This is being used to, okay, very much, and for the purpose of even whatever force, okay, which is set on the body while moving on the a circular path, that is centrifugal force used to say. So all these things we are calculating based on this equation. So, and also I want to say the acceleration. The acceleration is otherwise called centripetal acceleration. Okay, because it is all lateral only. It is all with respect to center only, not along the movement. So along the movement, you used to say, when there is a speed increase or decrease, in a straight path, there will be some acceleration. from one point to other point, when increasing, there will be acceleration. That is called, okay, longitudinal, okay, along the direction of the movement, acceleration or deceleration. But this acceleration because of the change in direction, okay, that used to say centripetal acceleration. That is equal to v squared by r. So again, you see, already you would have studied in your schooling that force equal to mass into acceleration. That is your Newton's second law. Okay, the force equal to mass into acceleration. So whatever force, centripetal or centrifugal force equal to mass into centripetal acceleration. Okay, the mass now, that is now weight of the body, considering the gravity due to acceleration. Okay, mass into acceleration equal to force. So this is finally we have the mass into centripetal acceleration. But centrifugal and centripetal acceleration are same in magnitude but opposite in direction. Okay, that we will see in the coming slides. Okay, so centripetal force or centrifugal force equal to mass into v squared by r. Okay, that is acceleration. And still, I want to make you clear. You see, let's take a ball and we are tying in a rope and we are rotating, we are swinging. Okay, above our head, it's rotating. That will be going on a circular path. So according to our, since you are swinging. In this case, whatever the force, available, existing in the string, the rope, that is called to centripetal force, that will be acting towards the center. So whatever force acting away from the this one ball, away from the center, that's called centrifugal force. Okay. See, the moment we are releasing the rope from our hand, what will happen? It will just go away and fly tangentially. So this is the difference between the centrifugal and centripetal force. Whatever the force acting towards center is called the centripetal force, and acting away from center is called centrifugal force. Okay, now let's see about the superelevation. What is the superelevation? You may be knowing superelevation is normally in the railway track, the outer rail is slightly kept higher than the inner rail. The difference in height is to say it is a superelevation or cant. Not only in the railway track but also in the highway that is being provided in the curvature. There is a difference in level we are keeping. There is outer and inner rail level or inner road level. Okay, so that is called to superelevation. So why it is provided? Let's see here. And the previous slides, we had been seeing about the centrifugal force and centripetal force, and both are same in magnitude but opposite direction. That is why it was in a equilibrium state and it is traveling in a circular path. Okay. But in the case of railway vehicle, so whenever it is traveling in a curved path, this is also subjected to the centrifugal force. Okay, centrifugal force, because of the change of direction takes place. And what is happening? The vehicle will be stable to some situation, to certain situation, and beyond a certain situation, limit, it will be unstable. Okay, it will be unstable. So that is why we have to calculate the amount of forces acting on the body, how much it is there, whether within the limit or also, or make it stable, and what it should be. Okay, done. So that we have to study and we have to do it. Okay. So here, as already discussed, the centrifugal force equal to mass into acceleration, that is acting away from the center. At the same time, body weight also will be acting. That will be falling on this the base, within the base. So once there are two forces, there will be a resultant force. Okay, so long the resultant force that falls within the base, it will be stable. When falls outside the base, okay, it will topple. Okay, it is unsafe, it will topple. That means this force will be more than the weight of the body. So that is dominating, because domination that will pull outside, and it will become unstable, and it will topple outside of the curve. Okay, so that you have to understand. So that is why always we should ensure the resultant force should fall within the base. Okay, when when we are making the resultant force exactly in the center of the base, it will be in a equilibrium conditions. Okay, there won't be any force acting there, just like a vehicle traveling in a straight path. That field will get, okay, when the resultant force falls exactly in the middle of the base. But we give some allowance. We cannot make it to fall like in the middle of the base, but to some extent, okay, within the base or 1/3, okay, it can fall, go here and there. Okay, so long the condition satisfies that situation, okay, it will be stable, it will be comfortable. When it is going beyond certain limit, it will become unstable. That we have to study here. So as we already discussed, centrifugal force equal to mass into acceleration. Mass means what? That is the weight of the body with respect to gravity. Considering the gravity, acceleration due to gravity. So W by G, weight of the body divided by acceleration due to gravity, is a mass. That into V squared by R. Here you can see here, more the speed, more will be the centrifugal force. Okay, more the speed, more will be centrifugal force. So because it is directly proportional. But R, if you take the R, because R, that is inversely proportional. Lesser the radius, more will be the force. So sharper radius will give more centrifugal force. Okay, larger radius, slightly comfortable. Okay, but as far as WBG is concerned, is constant for the particular vehicle body. Okay, so this is about the centrifugal force, and this is about the weight of the body. But for as already discussed, the resultant force somewhere it will be it will be between the centrifugal force and the weight of the body. It will be resultant force. So for making the resultant force falls exactly in the middle of the base, what we should do? Okay, we have to rise the base in order to make the resultant force falls in the middle of the base. We have to rise the outer right. Okay, amount equal to cant, amount equal to superelevation. Okay, so that how much you have to study here. Here, this is centrifugal force, this is the weight of the body, this is the resultant force. Okay, we are making to fall within the exactly in the middle of the base. The angle, this is a deflected angle is equal to theta. Let us assume the same angle. Okay, not to take, because the angle of elevation, so that we have to make it to perpendicular. This is the base. The result was exact should be middle. That means it should be perpendicular. Okay, and center of the base. So once so this is the theta, the same inclination we have to provide. This also theta. This 90 degree, this 90 degree. So both are similar triangles, and in a similar triangle principle, and we can just make an equation that cant amount of, that means E divided by G, E divided by G, gauge of the track, and E equal to cant or superelevation equal to CF, centrifugal force. This centrifugal force divided by weight. This. Okay, so this by this. Okay, this centrifugal, this by this equal to this by this. Okay, you getting it. So while we are further substituting, C centrifugal force equal to W V squared by GR divided by W, we will get that one. So again, the E equal to, so G will go up, GV squared by GR, W get cancelled as GV squared GR. So superelevation or cant equal to finally GV squared by GR. But 127 or how we got, I will just tell you, because substituting the value of G 9.81 and okay, and with the conversion, because now normally we used to substitute velocity, speed of the train in kilometer per hour, and whereas g is in meter per second. So with the conversion, we will be able to get approximately g v squared 127 r. Okay. This is something about the equation, formula for finding out the superelevation amount of current, how much it should be provided, in order to make the resultant force falls exactly in the middle of the base, so that when we are providing this much superelevation and for the particular speed, the resultant force falls exactly in the middle of the base, and it will be in equilibrium state, and as if the passenger will feel that not traveling in a car, but traveling in a straight path like that. Okay. So let's go to the slide, next slide again. So the previously we have seen g is squared equal to g by r. Again 9.81, we are substituting 9.81 meter per second, but whereas normally we used to substitute v in kilometer per hour. So v into 1000 by 3000 is conversion, if you follow in that. Okay. And v by 3.6, v by 3.6. When v squared by mean v by 3.6, 6.6, 3.6. So one more time we are multiplying. Okay. This conversion we are applying, and also 9.81. And so finally this will be your g squared by 127.138 r. Okay. When we are substituting g in meter, we'll get a value in meter. When we are substituting g in mm, okay, we'll get a count in mm. So normally this is your equation, and roughly approximately E equal to g squared by 127 r. This is my equation of finding out your superelevation. So where g is equal to dynamic gauge in mm, 1750. Though our track gauge is 1676 track gauge, track gauge, clear gauge, and we used to use your dynamic gauge. Dynamic gauge is center to center of our rail top, center to rail top to center of the rail top, the other side. Okay. So center to center of rail we are taking, that is 1750 mm pg. And v is equal to speed in kmph and r in meter, and E superelevation finally we are getting in mm. Okay. This is our superelevation formula. This is based on that we are going for the design of curvature and finding out superelevation, how much you are provided for the particular speed, or for the particular superelevation, how much we can permit the speed. Okay. All those things you can calculate. Okay. Then further reducing was simplifying this one, g squared for broad gauge. This is about 13.76 into v squared by r. Okay. So multiplying 1750, putting 1750 and 127, and we are getting this equation, 13.76 v squared by r. Okay. As I already discussed, what is superelevation? Yes, this is the superelevation means what the cant is a difference in the height between the inner and outer rail. Okay. Always the inner rail is considered to be a reference rail. For example, if you want to maintain a longitudinal level profile, the inner rail of the curve will be our base rail. Okay, with the reference. Okay. So that I want to mean here. Okay, as already discussed, that is being provided to counteract centrifugal force to ensure better comfort and for better distribution of load on both rails and for reduction of wear on the rail. Because of superelevation work, since we are making the resultant force exactly fall within the base or middle of the base, what will happen? There will be equal distribution of load on both rail. Okay, both rail will take place. So there will be reduction in wear on rail, because one more load on one rail means that will take more wear and tear. So that is being reduced here. And centrifugal force, because of the providing cant tilting of the track, the entire force, centrifugal force is nullified, centrifugal, okay, balanced, and finally the force, exactly resultant force falls within the base. Okay. So that's what I mean here. This the definition says. I mean, okay. Then coming to the equilibrium state, under definition also we can see here, equilibrium means what? Okay, that means what? That speed at which the exactly this force is balanced, centrifugal force is balanced, and the resultant force is exactly falls within the that means middle of the base. Center of gravity, the weight of the body exactly falls middle of the base. So that's okay. That speed is called, that's defined as a equilibrium speed. The current deficiency mean when train travels on a curve, when the speed when the speed of the train higher than the equilibrium speed. So in this case, the difference between the theoretical cant required for such higher speed and the actual cant provided is a cant efficiency. Because you see, we are calculating the how much super elevation is required, okay, for the equilibrium for the particular speed, but we are not providing that much. We are providing less, okay. We are providing less. Then there is a short of cant that called cant efficiency. Actually, we require more for the particular speed, but we are providing less. The difference is cant efficiency. Cant x means that is the excess cant. So actually, for the particular speed, how much cant required we are calculating using the equilibrium. Cant formula equal to the Gb squared by 127 R. But we are providing excess. Okay, slightly more providing. When you are providing more than the required, the difference will be the cant excess. Okay, that. Okay. How where it is occurs and all, when it is happening and all, and we'll see the next slide. That means as far as cant efficiency is concerned, normally it will be experienced by the high speed passenger trains. Okay, and cant excess normally will be experienced by the goods trains. Because as far as Indian Railway is concerned, we don't have any separate track. We are having only the same track, the same track, both high-speed trains and goods trains we are allowing. So in this case, both the speed, because high-speed trains normally will be running in 130 km/h, whereas our goods train will be running in 60 km/h. And both the speed situation has to be satisfied. That is why we have to keep the super elevation via media. So in this case, what will happen when high-speed trains are, running on a curve, that will experience cant efficiency, and goods train when running on a curve, that will experience cant excess. Okay. This is about the cant efficiency, cant excess, and equilibrium speed. And further developing the rate of change of cant and the rate of change of cant efficiency. That means normally that will take place in a transition portion, because as already discussed, we in our railway and we are connecting the circular curve with the straight, okay, by providing a transition curve. Okay, that is the cubic parabolic curve we are providing. In this transition length only, we are easing out the super elevation and the curvature. Okay, and here the easement, the easement should be such a way. There must be, the rate of change of cant or cant efficiency should be within the limit prescribed. This is a limiting value, just we will see on the next coming slides. For example, suppose 50 mm per second means what? So that means when a vehicle traveling at a maximum speed per meter will experience a change of cant or cant efficiency at the rate of 50 mm in each second. Okay, over distance, some distance. Okay. So that is rate of changes. How much change of cant, per second takes place? How much change of deficiency, cant efficiency takes place per second? That's called rate of change of cant or cant efficiency. There are limiting values, as we will see. And cant gradient means it is physically, normally we are providing 1 in 720 gradient. We are providing that is normally it is desirable gradient. Okay. That means 720 meter, 1 meter rise. Normally it is there. It should not be steeper than that one. And in exceptional cases, because site conditions, some problem is there, and now we are permitting 1 in up to we can go for 1 in 360 for 360 meter, 1 meter. That gradient we are permitting. So where there are how much this one? Based on that we are calculating the length of transitions. Okay, that safer length normally we are providing. That we will also see in the coming slides how the length of transition has to be calculated based on the rate of cant efficiency, and the cant gradient. Okay. And coming to the maximum permissible speed, you see the highest permissible highest speed per meter. Okay, that is maximum permissible speed. Considering the curvature, all those things, cant efficiency, cant excess, and length of transition, all those things. Okay, that is maximum permissible. That also we will see the coming slides. This is something about definition. Just you can, if you want to go in detail, understand, you can pause it and go through. Okay, understand. And now you can go for the limiting values. That is as per the IRPWM para 404, it stipulates the maximum CAD in Indian Railway, the group A and B routes 180 mm. Okay. Another thing, an existing track approval of CTE to be based on the clearance study and the corresponding increase in length of transition. Okay. See, now earlier it was 165 only. Now it has been increased to 185 for group A and B routes. Because why it is told, already 165 would be there, and there will be some structures, overhead structures will be there, like bridges and everything will be overhead structures. And further increase will affect the schedule dimension. That is why before increasing, applying this one, and it should be completely studied, and with the approval of CTE, Chief Track Engineer, and it should proceed further. Okay, for increasing supervision. Also, once we are increased supervision, automatically, the approach also should be eased out. Okay, for that, length of transition also should be increased. So, and for that, some complete realignment curve will be required, and also there will be obligatory points, OHE must, everything should be taken care, and it should be done. So, based on complete survey only, the exit track, we have to go for this one, 180. Of course, for new laying, new track and all, we can go up to 180 mm for group A and B routes. Okay, and 160 mm for other routes. That is the original provision statement. Okay, and CAN deficiency. CAN deficiency already discussed. That is the difference between the cant required for this one, cant required for that higher speed and the actual cant. Okay, that is called the cant deficiency. That is limited to, see here, 100 mm and 150 mm. Okay, that means for rolling stocks permitted with 150 mm cant efficiency, the cant efficiency should be limited to 150 mm on track with turnout with crossing on outer rail and on track with the expansion devices. That means SCG. See, so certain rolling stock have been permitted with 150 mm cant efficiency because such a way it has been designed, okay, to take care of the lean and all. That is why for particular rolling stock, and we can permit 150 mm cant efficiency, and provided should be free from turnout. That's the curve should not be with any points of crossing, should not be there on the turnout, on the curve, and also the expansion SCJ should not be there. Okay, when that is a situation, that is a condition, and it is limited to 115 only. Okay, otherwise you can go up to 150 mm. That is only for the nominated rolling stock. Which coach, rolling stock is permitted for 150 or 100 mm. Okay, that will be certified by the RDSO, and based on that, cant efficiency limit can be considered. And whatever may be, and when the curve with turnout or SCJ, it's limited to 115 only. Okay. So in other rolling stocks, 70 mm normally. So coming to the cant excess, already discussed. This is actually the difference between the actual cant available and the cant required for the lower speed, okay, good strength speed. So that difference is a cant excess. Okay, maximum cant deficiency available. Cant excess will try to keep because once there is availing full cant excess, what will happen? There will be load distribution to the inner rail. Normally. Okay, cant excess normally when it is there is a center of gravity. The weight of the body will be acting towards the inner rail only. So more load distribution will be inner rail, and there will be more wear and tear of the inner rail component. Okay, that will be experienced maximum. Okay, this is something about the cant excess. 70 mm limit is there. Okay, and rate of change of cant actual and rate of cant deficiency. The desirable is 50 mm per second. Already we have discussed. The definition we have seen. The 50 mm per second. Okay, the transitional portion. This is desirable. And maximum. Certain condition, situation, space constraint, or due to some reasons, and we are not able to follow this 50 mm. In that case, we can go up to 60 mm per second. And can gradient, of course, one in already told, 1 in 720, that is 1.4 ohm per meter twist, like twist. Okay, normally inner rail will be base rail, and outer rail will be, that is only the, gradient rail. Okay, let us take. That is so inner rail will be horizontal, plane, maintenance only, it will be inclined. So that 1 in 720 grade, normally it is preferable, it is desirable. That means 1.4 mm per meter twist. And in a situation, exceptional case, and steepest we can go up to 1 in 360, that is 2.8 mm per meter in case of space restriction. Okay, something. This you have to follow that. And coming to the design, aspects, curve, radius, you see, the radius, we cannot exactly fix it. That is based on so many conditions, site conditions, and speed potential, importance of the route, and all those things, based on that you have to decide. And some case, we want to provide a curve, but we can't provide because there will be some obligatory points. Something will obstacle will be there. So we can't. We can go this way. Okay. If you are going very close to the apex, that means that it will become sharper. It will become sharper curve. Sharper curve normally will be a problem because sharper curve means what? There will be more supervision will be involved. High speed train will not be able to permit, and if that is the case, we have to impose speed restriction on the curve. At the same time, when you are going for the flatter curve, that will need more area, large space we require. The length of the curve will be longer. So that we used to go via media between that. So based on this one, site condition, based on the route, importance of the route, and we will decide this radius. Okay. In general, normally, curve we will prefer 2 degree and flatter only because sharper the curve, it will become, more maintenance cost, more wear and tear will take place, and also, I told you, speed restrictions, and you cannot go for, long voltage rail track, sometime, and also when we have the points and crossing, and we have this one, contraflexor, like when the points and crossing we have one track takes off from the curve also, then there will be some limitations. So all those things, considering all those things and situation, and we have to decide the radius of the curve. Then however, the minimum radius in PG is 175 meter. Okay, we don't normally go up to this limit. However, it is we can go up to 175. That is permitted radius in PG. Okay, 175 meter. Okay, now we'll see about the formulae, or the formulae what we have for calculating the different parameters of the curve. Okay. So already we have seen the cant or superelevation equal to GV squared by 127 R, and simplified equation is 13.76 V squared by R, that is for broad gauge. Now we deal only broad gauge. Okay, it presents in the video. And that equilibrium speed is equal to VQ equal to 0.27 root of CQ R. This is just from this equation. Okay, cant equal to 13.76 V squared by R. From this equation we can find out the V. The V equilibrium speed equal to, we can reverse it and we can get this equation finally 0.27 into cant equilibrium into the radius. Okay. So this is about the equilibrium speed. So maximum spherical speed. So this equilibrium what for the particular superelevation, when you are running the speed, that exactly the centrifugal force will be balanced, and the center of gravity of the body. Okay, it will fall exactly in the middle of the piece. So for that, this is an equation. Okay. Then coming to the maximum permitted speed, you see Vm equal to 0.27 root of Ca plus Cd into R. That means that even we provide this cant, we can run this train still the higher speed. Okay, that means we give some allowance of Cd. Okay, as already discussed, some allowances for various routes. As well as based on the rolling stocks, they go in can deficiency 100 mm, 150 mm. Okay, so following that, no, so we can fix the maximum permissible section. Okay, this is the formulae for the super elevation and maximum permitted speed. Then coming to the length of transition, see, there are here also as already discussed, you have desirable and minimum. Okay, already we have seen the limiting values. Okay, here there are three conditions for fixing our length of transition. Three conditions. One is length is based on the rate of change of cant. Second one is rate of change of cant deficiency, and third one is the cant gradient, based on the cant gradient. So whichever is greater, so out of three formula, whatever value you are getting more, that will be our length of transition we have to fix. Okay, the first one, see, that is 1 by RCA into CA into VM. This is the formula. Because this is based on the 50 mm, because desirable normally already as discussed 50 mm per second rate of cant and cant efficiency, it was fixed, limiting value fixed like this, and a minimum value as we discussed 60 mm per second. Okay, so we'll come later for this. So for this 50 mm per second, if you are substituting here, we will get this one, because this 50 mm per second, it is mm per second, but whereas we are substituting speed in kilometer per hour, and duly applying the conversion factor, we will get 0.0056 C into VM. Okay. Similarly for cant efficiency, same thing, 0.0056 CD into VM. And cant here 1 in 720. So 1 in 720 means 0.72 into C into VM. Okay. This is cant actual. Okay, cant actual into VM. Whichever is greater, and we have to choose. And here minimum, this is based on 60 mm. So 60 mm means what? It will be 5/6 of 0.0056. If you are applying 60 mm and applying the conversion factor, keeping this formula as it is, and in terms of coefficient, we make this equation 5/6 into 0.0056 into CA into VM, and 5/6 of 0.0056 into CD into VM, and 0.36 into CA into VM. This is based on 1 in 360 gradient. Okay, cant gradient. Whichever is greater, we have to choose. Okay. This is the minimum one. This is desirable. This is only in the case of any space restriction, you have to go for that. Otherwise, normal, standard, and desirable and preferable is only this. Out of three equations, whatever value we are getting more, that will be our length of transition. Okay. Then, in case of compound curve, I already discussed in the previous video also. Compound curve means what? Okay, that two different radii. Okay, curve with two different arc with a different radius, bending in the same direction. Okay, that is normally your compound curve. That is a case. That is because of some space constraints, some obstructions. You will not be able to provide one single curve of same radius. Then one curve 1 degree, one 1 degree curve, then second 1.5 degree, sometime may be there. That is the case, at the junction and the joining point, and we have to use out the curve by providing suitable transition. If that is the case, this will be your length of transition, that is 0.0056, same thing. Whatever we have seen in the earlier formula, same coefficient into CA1. The first curve cant actual minus second curve cant actual into VM. Like that, L equal to length of transition equal to 0.0056 into CD, cant division is the first curve, and minus cant division of second curve into VM. Okay, and whichever is greater will be our this one, length of transition between the curves. However, you have to check up the cant gradient should be within the limit. There is 1 in 720, something like that. Okay. Then in case of reverse curve, this reverse curve means what? This is a two curve or same or different radii bending in opposite direction. Okay, normally used to say reverse curve. That is a case. This will be your length of transition, again 0.0056 into CA1 plus CA2. First curve cant actual plus second curve cant actual into Vm. Like that, L equal to 0.0056 into CD, can deviation into the first curve plus can deviation of second curve into Vm. So whichever greater value will be our length of transition in case of reverse curve. Okay, here one thing already note is there given as per engineering performance manual. The can gradient shall be within the limit as this is of course in case of desire minimum means 1 in 360 we must ensure. However, okay. Then second one for group A and B routes 50 mm straight or no straight in between. Suppose to reverse curve is there, in between one straight is there, straight we are put. Actually it should not be any straight, no straight also it is advisable as per the daily department, or if at all if it is straight it should be more than 50 meter. Okay, should be more than 50 meter. It should not be in between 0 and 50. It should not be less than 50 meter. Okay, you provide no straight, or if at all the straight it must be more than 50 meters. Okay, that's what it says. Otherwise, suppose no other way due to some problem, some issues, we are not able to even increase the length of straight portion more than 50, or we are not able to eliminate this one straight. If that is the case, we must impose the speed restriction of 130 kmph in the conversion. Okay, the speed is limited to 130 kmph. Okay, this is about the length of transition, how it's to be designed. Okay, we'll conclude this video with this. Thank you very much, and next video I will make it for the same subject of curve. I will make some exercises and examples. Okay, thank you very much.